Welcome to Falcon TV. Subscribe to the channel to stay informed and inspire us.
AI chips are specialized hardware devices that are designed to perform artificial intelligence tasks, such as machine learning, deep learning, computer vision, natural language processing, and speech recognition. AI chips are made by using different technologies and architectures, depending on the type and purpose of the chip. Some of the machines that make AI chips are photolithography machines. Photolithography machines are machines that use light and chemicals to create a pattern of the circuit on a silicon wafer. Photolithography machines are used to make ASICs, application-specific integrated circuits, which are custom-made chips that are optimized for a specific application or function. Some of the companies that make photolithography machines are ASML, Canon, and Nikon. Some of the countries that have photolithography machines are the Netherlands, Japan, and Taiwan. Programmable logic machines. Programmable logic machines are machines that use software tools to connect a large number of logic blocks and interconnects on a silicon chip. Programmable logic machines are used to make FPGAs, field programmable gate arrays, which are chips that can be configured and reconfigured by the user after they are manufactured. Some of the companies that make programmable logic machines are Xilinx, Intel, and Lattice. Some of the countries that have programmable logic machines are the United States, China, and Singapore. Parallel computing machines. Parallel computing machines are machines that use multiple cores or processors to perform computations simultaneously on a chip. Parallel computing machines are used to make GPUs, graphics processing units, which are chips that are originally designed for graphics rendering and gaming, but they can also be used for general-purpose computing and AI tasks. Some of the companies that make parallel computing machines are NVIDIA, AMD, and Qualcomm. Some of the countries that have parallel computing machines are the United States, South Korea, and Taiwan. The most powerful AI chip is hard to determine, as different AI chips have different strengths and limitations that make them suitable for different applications and scenarios. However, based on some benchmarks and metrics, such as performance, efficiency, flexibility, and scalability, some of the candidates for the most powerful AI chip are Google's TPU-v4. Google's TPU-v4 is the fourth generation of Google's tensor processing units, TPUs, which are ASICs that are used for deep learning inference and training. Google's TPU-v4 can deliver up to 420 teraflops of peak performance per chip, and up to 4.6 petaflops per pod, a cluster of 256 chips. Google's TPU-v4 is also compatible with TensorFlow, Google's open-source framework for machine learning. Google's TPU-v4 is used by Google Cloud Platform and Google Research for various AI applications, such as natural language understanding, computer vision, recommendation systems, and reinforcement learning. NVIDIA's A100. NVIDIA's A100 is the latest generation of NVIDIA's GPUs, which are used for deep learning training and inference. NVIDIA's A100 can deliver up to 312 teraflops of peak performance per chip, and up to 5 petaflops per DGX SuperPod, a cluster of 140 chips. NVIDIA's A100 is also compatible with CUDA, NVIDIA's platform for parallel computing. NVIDIA's A100 is used by various cloud providers and research institutions for various AI applications, such as natural language processing, computer vision, drug discovery, and climate modeling. Cerebra's CS2. Cerebra's CS2 is the second generation of Cerebra's wafer scale engine, WSE, which is a massive chip that covers an entire silicon wafer. Cerebra's CS2 can deliver up to 850 teraflops of peak performance per chip, and up to 2.6 petaflops per system, a single chip with a cooling unit. Cerebra's CS2 is also compatible with PyTorch and TensorFlow Lite, two popular frameworks for machine learning. Cerebra's CS2 is used by various customers and partners for various AI applications, such as natural language generation, computer vision, genomics, and cybersecurity. Everyone cannot make AI chips because making AI chips requires a lot of resources and expertise that are not easily available or accessible to everyone. Some of the challenges and barriers that prevent everyone from making AI chips are high cost. Making AI chips requires a lot of capital investment in equipment, materials, facilities, labor, research and development, and marketing. For example, building a photolithography machine can cost up to $150 million USD, while developing a new AI chip can cost up to $500 million USD. Moreover, making AI chips also involves a lot of operational and maintenance costs, such as electricity, water, cooling, testing, and quality control. Therefore, making AI chips is not affordable or profitable for everyone. High complexity. Making AI chips requires a lot of technical knowledge and skills in various fields and domains, such as physics, chemistry, engineering, mathematics, computer science, and artificial intelligence. For example, designing an AI chip involves understanding the principles and algorithms of machine learning and deep learning, as well as the architectures and components of the chip. Moreover, making AI chips also involves a lot of coordination and collaboration among different teams and stakeholders, such as designers, developers, manufacturers, suppliers, customers, and regulators. Therefore, making AI chips is not easy or simple for everyone. High competition. Making AI chips requires a lot of innovation and differentiation to stand out from the existing and emerging competitors in the market. For example, creating an AI chip involves finding a niche or a gap in the market, as well as developing a unique value proposition and a competitive advantage. Moreover, making AI chips also involves a lot of adaptation and evolution to keep up with the changing and growing demands and expectations of the users and the industry. Therefore, making AI chips is not safe or stable for everyone. The process to make AI chips is very complex, as it involves many steps and challenges that require a lot of resources and expertise. Here is a brief overview of the process to make AI chips. Design. The first step is to design the AI chip, which means defining the specifications, features, and functions of the chip, as well as the algorithms and architectures that will run on it. This step requires a lot of technical knowledge and skills in various fields and domains, such as physics, chemistry, engineering, mathematics, computer science, and artificial intelligence. The design of the AI chip also depends on the type and purpose of the chip, such as ASICs, application-specific integrated circuits, FPGAs, field programmable gate arrays, or GPUs, graphics processing units. Fabrication. The second step is to fabricate the AI chip, which means creating the physical structure and components of the chip on a silicon wafer. This step requires a lot of capital investment and equipment, such as photolithography machines, programmable logic machines, or parallel computing machines. The fabrication of the AI chip also depends on the technology and architecture of the chip, such as photolithography, programmable logic, or parallel computing. Testing. The third step is to test the AI chip, which means verifying the functionality and performance of the chip under different conditions and scenarios. This step requires a lot of operational and maintenance costs, such as electricity, water, cooling, testing, and quality control. The testing of the AI chip also depends on the application and scenario of the chip, such as deep learning inference and training, computer vision, natural language processing, or speech recognition. Packaging. The fourth step is to package the AI chip, which means enclosing and protecting the chip in a suitable casing or module. This step requires a lot of coordination and collaboration among different teams and stakeholders, such as designers, developers, manufacturers, suppliers, customers, and regulators. The packaging of the AI chip also depends on the form factor and interface of the chip, such as chips, modules, cards, or systems.
If you liked this video, please subscribe to the channel and give a thumbs up. Thank you.